Now, what I was saying is, in the last session, we were seeing on how to work on a Maven tool for doing the build management and creating a product. Now, after creating a product, pretty much, we'll have to do a testing, wherein, as part of the development lifecycle, there are different kind of testings that we will be doing. So let's try to understand why testing is needed, and in that, what are the different kind of testings that we have to do. So the most important thing in the development cycle is, after you have created the product, the quality of the product has to be ensured exactly on what we are expecting, so that the customer will be working on the product. So in that way, now to do the quality testing, we need to basically perform different kind of testings one after the other. So in that case, any kind of testing that you're going to perform, basically you are going to automate all the steps, because you're not going to keep doing all the tests one by one manually, because it will take a lot of time. So that is when the concept what we use is called as a test case, where test case is nothing but whatever steps that you're going to do to perform an actual testing to ensure the quality or the functionality or the behavior of a particular product, that we will try to write it in a test case. So that is how, when you say that you are testing a product, it is equivalent to the number of test cases that you're going to run, where each test cases is going to be matching specifically with the functionality what you want to test. So a test case is nothing but a specific step using which you will be testing a feature or a functionality of a product. So that way, when you say testing, it is running many test cases like this, through which you will be testing for a exact behavior of a product. So when we say testing, testing starts right from the time when a developer writes a code. So that is when the first level of testing that happens for a product is what we call it as a unit testing. So unit testing is something which will be done by the developer to verify whatever changes that he has done, where as a developer, he will be interested only to test the changes what he has done in terms of the code, and wherever the code is going to reflect in terms of functionality, only that he would like to test. That is what we say as a unit. Unit means only that particular area where a developer has changed, only that he will be doing a testing. So that's when, as soon as a developer modifies a code, before putting it into the repository, like before doing a commit, he will be doing a unit testing to make sure that whatever changes he has written or the code he has done is completely good. Okay, so that's when the first testing called unit testing happens. And after that, you will be doing something called as a integration test, where now, as a developer, if you modify a code, you will be testing that by doing a unit testing. But you still need to see whether that particular component, the unit which you have changed, should be working as a product together. So that is when the next level of testing that you will be doing is a integration. Integration means with his changes, is the complete product working together. So that is how integration is a test which we will be performing to ensure different parts or the components of our product is put together and it is working completely fine along with the changes what we have done as a developer. So usually a developer will be doing the integration testing after the unit testing to make sure all the changes are working as a product. Whereas in the unit testing, he will not be testing the whole product, only that particular component or a file which he has changed corresponding to it, he will be verifying it. Okay. Now, once the complete unit testing and integration testing is done, the changes will be committed to the repository, and then we will be creating a product, right? And while creating a product, we also do a testing. So that is when we were going through Maven, we saw a phase called test. So basically, what test do we do? So that kind of testing where we do as part of the build is what we call it as a smoke testing, where Smoke testing is actually not once again a complete functional testing. It is only a surface level testing. Surface level testing means once again we will just make sure whether all the changes that we have taken from the development, whether it is good to give it to the QA. That is, the product that we have created, right? It is completely working, so that whatever the developer has given, we have taken all the functionalities or all the changes, and then it is good to proceed to the QA. So such a kind of top level testing or the surface level testing, just to make sure everything is working fine, is what we do as part of the build lifecycle. So as part of the build lifecycle, we'll not be doing anything deep, wherein for some process you might also do a integration testing. So smoke testing can also be done where integrations can be done along with the smoke testing. So depending on the process, but pretty much smoke testing is something which we do when we are doing a build after the product is created, just to make sure that everything from a top level or from a higher level, everything is working fine, and whatever the developer has given the change, is it there in the product, so that we can give this product to the QA for the complete testing. So that level of testing, when that we do as part of doing the build management, is called as smoke testing. So smoke testing is done by us, that is as a DevOps engineer, where we will be trying to create the build of the product. So we will be basically doing this smoke testing, and when I say we will be automating the step, and as part of our build management or the build lifecycle process, we will be running the smoke testing. Okay, then once the smoke testing is done, the product actually moves on to the QA people, where in that the QA or the quality engineers or the quality assurance engineers, now they will be doing a complete functional testing. That is, whether the product is exactly working as per what you expected, whether if you give an input, you're properly getting an output, it is working functionally in all the ways that you want. So that is how the system testing is done by the actual QA, where they will be having a requirements which they have gathered for the product initially, and against that they will be trying to test each and every part of the product and try to verify whether that product is working functionally fully. Okay, so that is when the system testing is the actual functional testing which will be done by the QA. Okay, so once the system testing is done, now there is one more type of testing called as regression testing. Now, first of all, who does the regression testing? Anything after this will be done specifically by the QA. Now, when they have already done a system testing where they have completely tested the functionality, why do they need something called as regression? Basically, regression means repeating. So now let's take a scenario where we already had a change or a module, and on top of the existing module, you have modified something. So that is when we have a requirement where we are not just going to test only the new functionality, but as well as the functionality that we had previously should also be tested. Now, what I'm saying is, now let's say I create a small calculator application. First, I try to put a additional functionality to it. And for that, when you do a system testing, the QA will be trying to input data like 1 plus 1, 2 plus 2, whatever they will try to test. Okay, now that is the first time. Next, when a developer adds a new feature where not just to add two numbers, but to add three numbers also, it should be working. So that way, when we do a system testing, once again, the QA will completely test the product. But you are not just going to test only for more than three numbers or four numbers that you're going to add, but the first functionality, that is adding two numbers, should also be working. So that is when those kind of testing which you try to repeat, basically when a particular functionality has been modified which was already there. Okay, so those kind of testing which is done to test all the previous functionality is also working fine, is what we call it as regression testing. So regression testing, you are not just going to focus only on the actual requirement, but whatever that you already had which was working, which you had tested, you will try to test that once again as a complete product. So that is what we do as a regression testing. So regression testing will be done basically at the end, not to just check for one particular functionality, but completely as a product, whether everything is working with the new changes as well as the old changes, whatever that has been done, that should also be working. So that we take care as part of the regression testing. Okay. Then in some of the product, it is not going to be just a standalone product. When I say standalone product, it is just something which you run and get some output of it. So those kind of softwares or products is what we call it as standalone. Now, there are some web application where there will be more than one user accessing it. So those kind of scenarios where you have many people who are working on it, then it is quite important for us to check how exactly the particular software or the product is going to behave under different kind of load. Okay, so that kind of testing where we check whether the speed and the effectiveness of our product is the same whenever we have load put onto that product. So such a kind of testing to perform or validate the performance requirements is what we call it as a performance testing. So now performance testing will be done by logging as more users or trying to connect the same application many times as different users. For example, if you're creating a page where you have to log in, rather than logging in as one user, you will try to log in from different machines as different users at the same time. So you're just trying to check how is it going to perform on all the load and what is the output it is giving. Is it taking long time, or it hangs, or it takes very long time to load the page. So those kind of performance related testing to ensure whether the product is accessing and working effectively is what we call it as performance testing. So once again, performance testing will be done by QA, or there will be a separate group of people within the QA who will be focusing only on the performance testing. So you're not going to check the functionality, but you're going to check on how the software or the product is performing under different role. Okay, so that is when we will be using performance testing. Now, once you do all this kind of testing and you're completely fine with going ahead with the release, we will be actually doing one more testing before the release, and that is what we call it as a beta testing. Now, no matter what kind of testing that we do, we are just testing it assuming that a user might work in this way, and based on that, whatever requirements you have, we will be testing. But for certain products, it is always expected that we will give it to the end users or the customers and ask them to test and give us the feedback on how it is, so that everything is fine. Only then you go ahead and do a release. So such a kind of testing where before doing a release, you give the product only to a specific set of people who is going to actually use that tool, where it could be our customers, where we can ask them to help us with the testing, or we can have a specific team within the company where they will be testing it exactly like a customer and try to find out whether everything is working. So that kind of testing, especially that we are going to do before the release, which will be done by the end users or the customers or someone exactly like that, is what we call it as a beta testing. So especially if you're looking at the Windows operating system, many times you will be getting some software upgrades and they will be asking you, please verify and let us know. So that is when that is not an actual release. They will be calling it as a beta release. A beta release is nothing but they are giving us the product to test and verify for some time, and if everything is fine, only then after some time, based on the feedback that they are getting from this kind of release, they will take and then actually go ahead with the proper release or publish it as a complete product for the customers. So beta testing is the final testing where as a user we are just going to test if everything is going to work, wherein we can have dedicated people who will be working as a end user, or pretty much we can work with our customers or end users and give them the product for verifying in a real-time scenario. Okay, so that testing is what we call it as a final testing or a beta testing. Getting it on different kind of testing? Any questions on this before I move on? Okay. Now, moving ahead. So, as part of the software development lifecycle, there is one area called as code coverage. Okay, what exactly is a code coverage? Now, code coverage is a measure using which we will be describing to what level the code that you have written is executed. Which means, now let's understand this. When we are trying to do a unit test, what is that we are going to do? Basically, you are going to check only the functionality of that product is working fine or not. Correct? That way, now when a developer is writing 100 lines of code, okay, and when you try to execute that product using that 100 lines, are we sure whether all that 100 lines is actually being used to run the product? Because if a developer has written some unwanted lines, then it is actually going to cause some problem in terms of performance and maintenance effort. Because when you don't want 100 lines, then you don't have to write. So you have to write only the specific line of codes which will be converted into a product. And when you're running your product, we would know how and what exactly is being using. So that is how, by doing a testing, we will not be covering that part where we can try to tell from a given set of source code or a program, when we are trying to run a test, are we really capturing all the 100 lines of code and we are verifying? Okay, so that kind of check which we are going to do as part of our development lifecycle, where we are not just now focusing only on the testing of the functionality, but also we are going to measure on how many lines of code that you have, and when you ran a test, that is a unit test, how many lines of the code that you have written is being verified. So that way, out of 100 lines if you have written, are we really testing all the 100 lines, or we have been testing only a couple of lines, and is the product using all the 100 lines, or it is using lesser than that, wherein the remaining lines is unwanted. So like that, code coverage is a process using which we will be able to find out of given lines of code in a program, how much is actually being tested and how much is being actually used. Okay, so practically code coverage is a measurement of how many lines of code that we have trying to execute when the application is running. So that is the advantage, where now if you reduce these kind of unwanted lines of code, then the quality of the product will always be higher. So that is how the other way where we can improve the quality along with the different kind of testings that we did is code coverage. So now code coverage has to be done as part of our build management, where as soon as after you complete the build, we can do this process called code coverage, which will help us now to determine how much of code is being really tested and how much is not being tested. So as I said, if you have 100 lines of code written in your program, and when you test, you're actually testing only the 80 lines of code. That means 20 lines of code is not being tested. And out of that, do we really need that code? Because if you're not testing, that means you're not using it. So that way, if you have any kind of dead code means a code which is of no use for us, unnecessarily we have written. So we will be easily able to find out those kind of code which is not being used, and we can remove without it is going to affect the performance of our product's result. So that way, it will always be helpful. Through code coverage step, we will find out how much of code is being used and how much is not being used. And not only that, what if for doing the testing, we will be writing a test case? That is what I said. So if you want to check something, what and all you are going to do, that you will put it as a test case, and the test case is what we will be running. That way, if there is a problem in the test case itself, that you have written the test case in such a way that it will be covering only the 80 lines, where we have missed to include the 20 lines, then those kind of things can also be tracked, where code coverage will clearly say that, hey, out of 100 lines, you have used only 80 lines to test. That means remaining 20 lines is not being used. So please check whether you want to test it. And in case if you have missed it, then make sure you add your testing to cover these remaining 20 lines also. So that is how code coverage will also help us to find out whether if there are some lines of code which has not been tracked by a test case, we can add more test case to test that also, and we'll be getting a better quality. Okay, so by that, now when you try to run this process called code coverage, it is going to actually give us some kind of value by which we can determine how many lines of code has been tested, how many lines of code has been tracked or been used when you run the application. So that way, if you have a code coverage being generated for a product, then higher the code coverage means there are lower chances of having a bug which we don't know, because as much of code coverage is being completed, and the code coverage rate is always high for a product, which means you are actually testing the product in a higher way, and you are making sure that all the code that you have written for that product is being captured thoroughly. So that is how we can confidently say that there are lesser chances of getting a undetected bug, a new bug which you never expected. Those kind of things can always be eliminated. Thus, code quality will also help us in doing the quality increasing of our product. Okay, so as I said, when will we be doing the code coverage? Basically, we will be doing the code coverage as part of our build step, where additionally, after creating a package, you can run the step called as code coverage. Now, the code coverage details will be given by the developer, because they are the one who will be deciding what to test and how to test, and in that what kind of output that we should get, everything will be done by them, whereas we will be helping them in assisting or adding that kind of code coverage step to our build. Like I said, so you will be given a plugin. For that plugin, you should be adding it as part of our Maven's lifecycle, and you should be calling, so that at the end of running the code coverage as a new step, you will be getting some output, which we will be sharing it with the development team, where they can know that for this set of code that we have, this much of code coverage has been obtained, and in this, how many code has been used, how many code has been not used, how much of testing has been done, and how much of testing has not been done. Everything can be easily tracked. Okay, so we are going to help in adding this process to the development cycle or to the build management step, whereas all this input will be given by the development team. In that, now, what is that exactly you are going to do as part of the coverage? So basically, when you are saying code coverage, there are several ways of doing it. The first one is function coverage. Function coverage means, now if you see a program, especially, we call it as a subroutine or a function, where you will be grouping certain lines of code together, and then we call it as a function. So that way, if you have a program, in that program, whatever functions is there, you want to check whether all the functions has been used or not, or whether it has been called or not, then you will be doing a function coverage to test and verify those kind of details. Suppose if you want to verify whether each and every line of your program, that is the statement, has to be used or not, then the second criteria that we will use is statement coverage. So using the statement coverage, you are going to check only on the number of lines and whether each and every line is actually used or not. So that way you will verify everything based on line by line through statement coverage. Suppose once again, when you are writing program, we will be writing a program with some conditions, whether if a situation is there, you do or run the program in this way, and if it is not there, then you execute something in a different way. So those kind of conditions that if you have and you want to test both the conditions, whether the condition is true, what you have to do, and the condition is not true, what it has to do. So that way, whether your code is actually testing both the things, whether the condition is matching or whether the condition is not matching, are you trying to test and verify all the code? Those kind of scenarios is what we are going to verify using branch coverage. Okay, and now it is once again on top of it, you are going to add it specifically using condition coverage, where you will say not just on one condition but also on the other condition, whether it is failing or passing or the condition is true or fail. You match all the scenarios and see whether the code is being verified or it is being running for both the scenarios. So that is how, using this different kind of criteria, we will be able to capture whether given a program all the lines are being actually tested and whether when you run your program all these line of code has been really used. Okay, so that way now when you run code coverage, you will be using specific tool for it. So just like how we have tool for SEM, how we had tool for build management, for doing code coverage we have specific tool. And what was that? Branch and what is the other one? Okay, see, it's almost same. Now what I'm saying is, now let's say you have written a program in which you are writing a condition. Okay, now let's say I'm writing a program which should say if the user is Adam, then it should just print me hello Adam. Okay, this is the condition I'm giving. Suppose if you are interested to only check whether the code whatever that you are testing will only verify if the user is equal to Adam, then those kind of checking for condition specifically is what we call it as a condition. But now I don't just want to check one condition, but in case if the user is not Adam, you should have been telling something else. Say if the user is not Adam, then it should say you are not Adam. So that case, if you have something else that has to be done, if the condition is not matching or the condition is failing, or these kind of situation has been tested or verified, is what we try to check as part of the branch coverage. So all the decisions, not only this, but whether on all the conditions, if the condition is matching, it should check this, whereas if the condition is not matching, it should also check this. So both ways of testing has to be done, and whether your code is doing all those things is what we call it as a branch. Whereas condition means the code has been written in only such a way that it will check for only one condition, but on both the decisions if you want to check, then you call it as a branch criteria. Getting it? Okay, now again, this is more of theoretical because we need to understand when a developer is writing. it will be helpful for us if you know the concepts, what exactly he's trying to do. But again, we are not going to write any test case, but we are going to help in assisting the automation for this. So that way, specifically when you are working on Java program, for Java, there are certain code coverage tools that you will be using like JTest, Cobertura, Emma, or Jacob, Chocaco. So all these are different tools using which for a Java program you can run them, and using that you will be trying to get how many lines of code is being executed when application is running and how much of line of code is being actually tested. All those things can be done. So all these things are different kinds of tools. So that way, when you actually run this, you will be getting the output in terms of percentage. So the percentage that what you get is, this is your line. In this line, you have so much of functions, so much of statement, so much of condition, and in that, how much you have actually captured. So that way, it is going to give the percentage in terms of how much of line of code has been actually verified or used. So for example, if I have 200 lines, and out of 200 lines, if I have actually used 180 lines and the remaining 20 lines is not used, then the code coverage will be percentage, where how much is 120 out of 200? Sorry, 180 out of 200. No guess? Guess it. How much? It's going to be close to 90%, right? Yeah. The same thing if I say, if you have only evaluated and the output that you're getting is 160 lines, then it's close to how much? 80%. Okay, so that way the output that you're going to get from the code coverage is the percentage, where you can say out of this many lines that you have, this is the percentage of code coverage. So it will be always in terms of percentage. So it is always better to make sure the percentage of code coverage is 100%, because if you make sure that anything near to 100%, then it is actually good that the product can be better quality. Okay, but it is not practical to achieve 100% of code coverage anywhere, because it depends on various factors. One of the thing is cost of failure. Now, why are you really interested in finding out whether the code is going to work and how much of line of code that is being used? That is because if the code has not been tested or not used, is it going to cause some issue for the performance? So that is what we call it as cost of failure. Suppose if you are not interested in those kind of failures, then it is okay for us even if the code coverage is little less. So practically, depending on the product, the code coverage will be varying. That is, the expectation for the code coverage will be varying. Then it also depends on what is the software and hardware which will be used by different people. Now, whatever that I am using could be a different, and because of this, I might be getting a different output. The same thing, if other person is using the same software in a different way, you're going to different output. So that is how you cannot just directly say that 100% of code coverage is expected. So it is going to change. And then in some cases, let's say you didn't had a concept of code coverage at all in your project, and suddenly you are trying to add this into your project at the end of the release. That time if you try to add, then it is not going to change anything much. So that is how, what will be the advantage by adding it in between. So that way we are going to see the use of it. So based on when you are going to add the project, and for that when you are going to add the code coverage, it matters a lot. So once again, the coverage report or the percentage depends on that again, and as well as what is the priority of your project. Now sometimes the performance is always important, but few test cases or few errors are negligible. They will say that okay, it is okay to have this, but more important, I want to fix you some other thing. So that way the code coverage report will be changing. So that's how, if you see an ideal percentage that we should be expecting for a project, anywhere near to 80 to 90% is actually good. But if you have anything more than 90%, then you can say that's a very good product where we can assure the quality of the product is always higher. So that is when through the DevOps engineering, you're going to focus on such a way that the product is not only built, as well as you're going to do the testing, as well as you're going to cover the code coverage and generate the report and give it to the development team so that they can check and ensure the quality of the product at any point of time. Getting it? What exactly is code coverage? Did you guys get what is the code coverage? Okay, now if you want to implement code coverage, now once again, as I said, they have a lot of tools where now when we want to include this as part of our build management, then we know that specifically from Maven, anything that you want to add is all about plugin management. So that is when now specifically for code coverage, we have plugins. That way, one of the most popular tool that we will be using along with Maven for doing the code coverage report generation is what we call it as Cobertura tool. Okay, so for working on Cobertura, we have a tool called, or a plugin called Cobertura Maven plugin, which we will be using to run this particular Maven build, from where it will try to use this Cobertura tool and generate the code coverage. Okay, so once again, if you're going to use a plugin, what is that you have to do? You have to first form the structure, and in that you are going to get the GAV of this, and then you have to give certain configuration value where the output of your Cobertura will be a XML file which will have the report on what is the percentage of code coverage that you have done. Okay, suppose if you are interested to run this against your project, then simply take this as an example. Let's go to a project. Okay, and let me take the module 2, and in the module 2 let's add this. Now we had all the plugin that we added yesterday. Just to see it clearly, I'll remove and then add. So if you're adding to an existing set of plugins, then you have to add only this, but here I'm just replacing and I'll put it up. And now if you want to call this plugin, either you can attach this plugin to a particular phase by giving the phase step and say which phase of the Maven's lifecycle where you want to call. But pretty much we will be running the code coverage using Cobertura at the end after creating the package or after doing the deployment as the last step you're going to run, because this is nowhere dependent on the actual build process. It is only something additionally you are going to do after creating your product to verify how much of code coverage has been done. So that way, to call this plugin directly, we have a specific goal called Cobertura : So this will directly call this plugin and it will execute. And if you have created a project for that, whatever files you have, it will try to read and verify everything whether it has been used or not. Okay, so that's how it is going to use it. So just run it quickly and verify. Now, don't worry about the steps, because this is the same thing we will be doing later, where we don't want to use Maven directly, but instead we will be using Jenkins, and from Jenkins we will be automating, because now I have to run it 2 times. First I will say Maven package, and then I have to call this. So instead of doing it, we can directly use Jenkins to automate the complete software configuration management process as well as the build management. Okay, so in that, now to just have an overview, if you ran this, you would have got an output on your target, because in Maven we know any output that it is going to generate will be respectively in a folder called target, and inside that, now you should have got a new folder called Kobertura, and inside that there is a file. So this is the file which will be having all the information. So the development team can make use of this, and if they particularly publish it to any place, they will be getting the result. And again, there are tools using which you will be publishing this output and see what is the code coverage that you have done. But ideally, this file has the complete details about how much of code coverage has been done and what is the percentage of that coverage. Everything will be present in it. So like this, all we have to do is, for whatever project we have, we will just make use of a plugin, and using that plugin we will be attaching it to our project and call it whenever we need, where the configuration values might be changing based on what kind of output you want, what are the different things that you want to do. So those things again we'll cover very deeply in the continuous integration. Through Jenkins you have all the future, but here it's most of a command line way, wherein if you want to add a plugin, you can simply add in the same structure by knowing the GAV and giving the specific configuration. Okay, but more importantly, understand there's a concept called as code coverage, which will be done as part of your build management, where you will be doing it after you are creating your package. That is as the last step for your build management. Getting it? Is that clear? Hello? Hari, Kavya, guys, please speak up. If not, I won't be knowing if you guys are on mute.
Yes, sir, we are getting.
Yeah, please let me know. If not,
Yeah, sure, sure.
I won't be knowing. Yeah.
Actually, we are not from the programmers end. No, that's why it's a bit confusing. Actually,
Now, that's the reason I'm
I
trying.
think
We will.
the people who are from the programming end, they will understand clearly.
Yeah, but at least are you understanding the concept? Because I'm not going in.
Yes, yes, concept. We are getting the concept.
Yeah, we will see all those things. But see, from us, it is pretty much we need to understand the concept. We don't have to know what exactly the coding is going to do. But now, given a chance, why you are doing a code coverage, you should be able to answer them. And what is the advantage we are going to get? That is what we are trying to understand. And from that, what exactly you are going to run. So that is what we are trying to understand.
Okay, okay.
Okay. Now, still, if you're focusing on the code quality, now we said that as part of DevOps engineering, we are going to equally focus on the quality of the product, where along with the testing, there is one area called code coverage, where we are going to run something which will help us to generate some percentage, which we will be giving to the developers or the program managers, using which they can verify what is the quality of the product or the code what they have written. It is for them. Now, along with it, that is along with the code coverage, there is one more concept called source code analysis. Okay, don't get confused, try to be clear. So far on code coverage, as the name says, what is that you are covering? Your coverage means you are trying to check whether you have actually using all the code that has been written. So that whatever you are going to do is called as code coverage. But now, if you look in other way, if you have written a code, now there might be some security issues in it, because as of now in the software market, one of the important thing that we need to also focus equally is how secure is our software. Correct? So that way there could be some kind of code which you have written which could cause some kind of configuration or a analysis where it could be creating a security concerns. So that is when we are not just interested now as an organization, we are not just interested only to test the product or create the product or just try to verify how many lines of code you have written and whether you have already or whether you are testing all those lines of code is not just sufficient. But what is more important along with that is we need to now find out whether the code whatever that you have written is actually causing any problem in terms of security. So that is when if there is any specific violation that we are trying to do by writing a code, we need to find out. So such a kind of process using which we are not just looking at how many lines has been used, but whatever the lines of code you have written, is it actually a standard code? Are you following the standard? Is it causing any problem in terms of security is what we are trying to do using a process called source code analysis. Now, how can we do this? Basically, if I give you a file with 100 lines, there can be one person or there can be a person in the team who can go through your code line by line and say, okay, now you have written all this code, but I feel that when you run this code, there might be a security issue or you have not followed the standard, and because of that, there might be some problem. So those kind of things can be done, but pretty much it will not be possible to test each and every file because you might be having thousands of files in your product and each file can have thousands of lines. So that is when if you ask someone to manually review your code and try to find out if there are any standard issues or if there is any security issue, then it is going to be too expensive in terms of time and money. So that is when we are going to implement the source code analysis step using an automated way through DevOps. So in that, how exactly you're going to do? So the source code analysis, whatever that we are going to do, right? So basically, what we are going to do in this, we are going to take a file. So when I say source code, what exactly is a source code? The actual raw file, that is the Java file or the C file in which you have written the code. That is what we call it as source code. So those kind of files will be verified whether it is actually safe and secure and the quality is as expected as you want. So in that way, in the source code, with source code analysis, we will be trying to ensure that if there is various kind of issues that we will not be able to find by just running general testing. So those kind of advanced errors specifically for the developers, okay, there are different kind of functional program. Now sometimes they might be writing a code which works on mathematics. In that, the code they have written in such a way that if a number has to be divisible by another number and that number is 0, then you are going to actually get some infinite number or you're going to get some junk value where your program might get stuck. So those kind of rare scenarios you can actually find out by using the source code analysis. And not only that, we call something as memory leakage. So pretty much when you're running your product, it is going to consume some memory, that is RAM of your machine or your server. So in that case, the code that you have written, if it is going to consume too much of memory, then once again there will be a problem in the performance. So those kind of performance or the memory issues that is going to occur, can easily be found out using source code analysis. And other than that, if there is any new issues which is unexpected, that can also be found using the source code analysis. Okay, so finally, if you look, for doing a source code analysis, you don't need the product at all, because source code analysis is different and code coverage is different. Code coverage means you are trying to find out if you run a program, how much of line is being executed. So for that, you need to practically run each and every Java file and try to find out. But for codes analysis, that is the source code analysis, you are just trying to check if you have written 100 lines, whether the 100 lines is of the exact quality. You are not checking whether the 100 lines is tested or used, but you are saying whether the 100 lines is written with the proper standard, or is there any problem in the code what you have written. So that way, to do a source code analysis, you don't even have to create a product or do the build. If you want, you can pretty much do it even before the build. Okay, so the source code analysis doesn't depend on your product build, which means you don't have to execute your code to run a source code analysis. Okay, that is what it means. Now, the benefits what we are going to get, as I said, first of all, by running the source code analysis, you are going to check all the code that you have written in your project, so that if there are any issues in terms of security that is there, you have a higher chances of finding it before you are going to give it to the customer or the end user, and they coming back later saying that, hey, I'm trying to run something, but I see that your project is having a security issue. So those kind of major concerns that we can find out before we do the release by doing a source code analysis. And what exactly do you mean by checking each and every code? Now, when you say IT software, a program language, everything has a standard. So that is how there is a coding standard for each and every program, and there is a coding standard with respect to each and every software, and each and every country has a specific coding structure also. So that is when we have to make sure whether we are following all those. So in that, what exactly we will be doing in source code analysis is, you will be writing some standard rules, or you will be defining what is that standard with the help of developer, where the developer will say that this code, if you are writing, this is how it should be. So like that, you will be creating different kind of rules for different kind of programming language, or for the same program you will be having many syntaxes, right? So all those things will be defined, and you are going to verify each one of them against all the code. So that is how you will be verifying all the code and try to find out whether the code that you have written is exactly matching the standard what you wanted. In case if it is not following, then it will give you the details of it. Okay. So now coming to the point, when is that we will be using source code analysis, and why is it important for us as part of the development cycle? So usually, when do you have the complete code written and given to the QA? Only when we realize that the development is done and we have moved to the QA. And exactly when you do the build process, that is when you have all the code with you, correct? So basically, the source code analysis will be part of the build process again. That is when, being in DevOps engineering, we should also understand what do you mean by source code analysis, where we will be helping the development team to find out if there are any problems in terms of security concerns or a bug which is not found. We can easily find it at an earlier stage, so that it will be easy for us to fix rather it is causing a major problem. So that way, the code coverage and source code analysis will be run at the same time after the build. Because once again, source code analysis doesn't need to run the program. You just have to run. But the major concern what we have is, first we will create the product, and then you will try to run the code coverage, and you will be running the source code analysis. Or pretty much after creating the build, you can run the source code analysis and then do the code coverage. So that's not a problem, but the code coverage and the source code analysis has to be part of your build process, and it has to be at the end. So that is the major importance. So that way, now by doing a source code analysis, we will ensure that the kind of warnings or the errors that you're going to get by executing your program will be as less as possible. And if at any point of time we are getting such a kind of issue, we will be identifying it very early in the development itself. And because of that, we will not be taking longer time for waiting for the bug to fix and introducing ourselves to new issues which we didn't expect. So that will help us to do the release cycles faster. So that's when, along with the product build, it is quite important that we need to understand what is source code analysis and what is the coverage report. Okay. Once again, for different kind of programming languages, we have different kind of source code analysis tool. Okay, now specific to each program you have tool. Now in case if you're trying to do a source code analysis for C++, then you have tool like clang or cpp check. In case if you're trying to do a code analysis for a PHP code, then you have something called as rips. If you are trying to check for Python or Perl, specific to that, you have pycharm or perl-td. And specifically for Java programming, you have tools like checkstyle, findbugs, eclipse. In that series, one of the latest tool where companies are using is what we call it as SonarQube. Okay, so now if you want to include SonarQube, then once again you will be using a particular plugin for Sonar, because unlike other tools, Sonar is going to be a specific tool which you need to install and configure. And for using it in the Maven, you will be just using a plugin where once you give the plugins GAV, and if you want to invoke, you can directly call Maven sonar and it will try to run. Okay, either this way you can do, or the other way, as I said, you can call it using the Jenkins, where we don't want everything to be done from Maven, but pretty much we can do it from the Jenkins, where internally we are going to attach the Maven to this tool called Sonar, and through that we will be calling it. Okay, now to set up Sonar, it's quite simple. Now only thing that we need to know is we need Java 1.8. Now this is one of the problem why when I was trying to show you this JBoss application running, it didn't work, because I had Sonar installed my machine for the setup, and in that I have upgraded my machine to Java 1.8, and because of that the JBoss application server was not working, because that needs 1.7. Okay, so now how do you install SonarQube? So let's have a quick overview today. So specifically, if you want to install Sonar, make sure on your machine or whatever machine in which you are trying to install, you will have Java 1.8. Okay, so then go to this particular site which has all the details about how to do. So let's go through this one by one quickly. So now when you are trying to install SonarQube, basically first thing is, depending on what kind of platform that you're working, you try to download the file. Okay, so if you click on this, it will be trying to give you a zip file which you try to extract to some directory, and all you have to do is, once you have extracted, you should be just running it. So now if you download this to a particular location, then from that location, if you extract it, you will be getting a folder like this. Okay, suppose if you have extracted it on Windows, you go to the location where you have extracted, and from that you call this batch file. The same thing, suppose if you're trying to install it on a Linux machine, wherever you have installed, go to that bin folder, and from that you call the sonar.sh script. So let me see if I have installed Sonar. Okay. Let me check. Okay, here. So what I've done is basically I have the Sonar here. This is the file that you will be downloading. So if you download this, basically you will be getting this first. You'll be getting this file. Okay, and now if you extract it to some location, then that particular location will have the details. Now, for example, let me try to extract it here. So it is asking, do you want me to extract in this folder? Okay, go ahead. Okay, now this is where I have extracted, and looking at this, it says wherever you have extracted to that location, you will be having a bin folder. In that, go to the specific platform related directory. So this is where I extracted in the bin. If I go, I can see now there are platform related files because it is the same zip file which you are going to extract, whether it is Windows or Linux. In this, I am basically using a Windows 10, which is nothing but a 64-bit machine. So I'll go inside it, and in this, what you have to do is you can see a batch file called as Sonar batch. So now you're going to call this. So that you're going to do from the command line. So I am in this location. That's exactly what's been defined here. And in this, you just call the start sonar.bat. Okay. So now before that, I said you need to make sure that you have Java 1.8. So make sure Java 1.8 is there. If not, Sonar will not work. Okay, so try to download Java 1.8 and install on your machine, and now Java is available. So now if I call start Sonar, it is going to run. Now Sonar is quite popular tool. That is because it is going to use a web interface. It's not like other tools where you'll be using command prompt. It is more of a UI tool. So that is when we will be helping the developers in installing and configuring. Whereas in addition to that, we will run the build step where we will generate some data and we will put into the Sonar Cube, and that will be published into the particular web page through which you will be accessing the Sonar. Okay, but other than that, it is the developers who will have to define what is the standard or the rule, and based on that, we will be running the project. Okay, so it is bringing it up. So once the Sonar is up and running, you can basically access it. Okay, so now once it is installed, if you go to 9000 port on your current machine, you can access the Sonar Cube running. So localhost means I am installing Sonar on my same machine. So same way, if you have installed Sonar on some other machine, you will give the machine name where you have installed Sonar. But as of now, since I have installed on my machine itself, simply you can say from the web URL http localhost:9000, because this is the port on which Sonar will be running. So once it is running, you can pretty much, when you go and enter, you can access the Sonar Cube. So as of now, you can see I am accessing the Sonar Cube, which we have just extracted and running. Okay, and for the Sonar Cube, you need to create a user account, but by default, you will be allowed with a username called admin, and the password is once again admin. So now we have simply installed SonarQube, which is very simple, and we are ready to use it, wherein we will be taking care of only the installation and the administration. But here you have a concept called rules, where there are different kind of rules which comes along with the SonarQube. That is the advantage, where you don't have to specify. For example, if you look at Java, so for Java, it is giving different kind of rules. So where each rule specifies that this is how you should be writing your code. So that way, when you are trying to execute the SonarQube against your product, it will try to check for each and every line of the code against all the rules that you have. And if anywhere any problem is there, it will try to notify us. That's the advantage. You will make sure that there is no problem in the security, or we are always following the standard that is needed. But in addition, if you want to write any new rule, you can add it. That will be done by the developer, because we will not be knowing the coding. So we will take the help of the developer. They will add new code and we will be just running our project. Okay. So quickly, to just show you how it works. Now, when you run Sonar, whatever that we have installed, now it is only the web page. Okay. But for running Sonar against our project, there is one more small tool called SonarQube Scanner, which comes along with it. So if you go back to the installation page, now there is one more thing called a SonarQube Scanner, which is needed to run, where this SonarQube is the server which we are seeing it here. This is only for accessing the web page, whereas the other Sonar Scanner is the one which we will be running it against our project exactly. Try to understand. SonarQube is the web application that we are going to see whatever output we are going to put. But for running the code analysis, we will be using something called as SonarQube Scanner, and only this will be running and capturing the details based on how many Java files we have and how many lines of code it is there. And then with respect to whatever data that this generates, we will be putting that into the SonarQube web page and we'll be seeing it. Okay, so that is what we are going to do. So that way, now if you download, once again, you're going to get a folder like this, Sonar Scanner. So if you extract this, once again, here you can see that you have to go to the particular folder. Okay, that is the folder where you have the bin, and in this there is a batch file called as Sonar Scanner. Okay, so if you run this against your project, then automatically the Sonar Scanner will read all the information from your project, and that it will put it to the SonarQube what you have installed. Okay, now whenever you are running SonarQube has to be installed on the same machine from where you are doing the build. So that is how we don't have to do much configuration to tell Maven or any build tool on where exactly is the SonarQube available. By default, it will consume, or it will assume that SonarQube is installed on the same machine and it is running on a port number called 9000, and it will try to access. Okay, so that way, now to run this, if you go, simply you can give this and you can add to the project and run. So this is one way of running, where I can add the GAV of the SonarQube related plugin for Maven, because you are going to run this from the Maven. That is, as part of the Maven build step, if you are trying to invoke, then you can add it up this way. So I can use, now if I want to call this directly, once again, you will just use a specific goal associated. Now every plugin has its own goal. So now we are going to call this. Now when you call, it is basically going to get the details. Okay, what is it saying? Line 35. Some issue. Okay, here. I didn't close. Now you run. It is going to call only the Sonar plugin. And now if you see related to that, whatever files it is needed, it is trying to download, and it is generating the source code analysis. It is trying to get all the details, and automatically you can see that it is trying to connect to your Sonar Cube, which is running on your machine. By default, it will assume that you have installed Sonar Cube on your machine and it will access. But if you have not installed, then you have to give all the details about where exactly is your Sonar Cube. Okay, that we will see it again with Jenkins. But right now, without doing much, if I just run that particular goal, you can see it is generating and it is trying to copy everything. So if you go back to your Sonar Cube, sorry, this one. Now you can see that there is a project under it, correct? And if you click on this, you can see that it is going to give you the complete details about how the code has been written and what kind of analysis it has done. So basically, it is saying that it has not found any kind of bug, as well as it is going to say you have basically 8 lines of code, and out of them how much has been covered, from watch file it is trying to get it. Okay, and if there are any kind of issues, or have you written any duplicated code, which means the same code have you written it again and again, then try to remove. So each and every details it will be trying to give here, where you can click on this and each one you can find out what exactly the issue that the code has. So as part of our build process, we will run this, and the developers will go to this particular location and they will try to see for that project what is the output that they have get and what is that particular issue that they are facing. Okay, so that's how they are going to try to verify it. Getting it? And what do you mean by code coverage, source code analysis? Now with this understanding, when we are setting up the continuous integration process, we will do all these things using Jenkins, where in addition to this we'll also be doing a couple of more. So now if you understand, if I say build management, it is not just about creating the product, it is trying to run the smoke test, it is trying to do a deployment, as well as you are going to do a code coverage report, source code analysis, and ensure that the product is created fine, as well as the quality of the product is also good. Getting it? The importance on why build management is so critical as part of our release or as part of a development lifecycle.